Imagine looking out into the night sky and realizing that everything we see, all the stars, galaxies, and cosmic structures, might be sitting inside an enormous bubble, a vast region of space that is emptier than average. Could it be that we live in a cosmic void? And if so, what would that mean for our understanding of the universe, and for some of the deepest mysteries in modern cosmology? Today we're going to explore this fascinating idea, a question that has intrigued astronomers and cosmologists for decades. So first, let's take a step back. When we think about the universe on large scales, it's natural to imagine it as being more or less uniform, with galaxies scattered evenly throughout space. But that's not what we actually see. Thanks to powerful telescopes and large-scale surveys of the sky, we've mapped out the distribution of galaxies across hundreds of millions of light years. And the picture that emerges is striking. The universe resembles a vast cosmic web. This web is made up of filaments, long, thread-like structures packed with galaxies and dark matter, and at the intersections of these filaments are clusters and superclusters of galaxies. But between these filaments, there are enormous empty regions, which we call voids. These voids are not completely empty. They contain dark matter, some gas, and a few lonely galaxies. But compared to the cosmic average, they are regions of striking emptiness. And they can be truly colossal. Some voids span hundreds of millions of light years across. So what about us? Are we inside one of these vast empty regions? The idea isn't as far-fetched as it might sound. Our Milky Way galaxy is part of a larger structure called the Local Group, and that in turn is on the edge of a structure known as the Virgo supercluster. But beyond this, surveys of our cosmic neighborhood have identified a region called the Local Void. This is an area that appears to be underdense, meaning it contains fewer galaxies and less matter than average. Now, why does it matter whether we live in a cosmic void? Well, one of the biggest mysteries in modern cosmology is that the universe is expanding faster and faster over time. Observations of distant supernovae in the late 1990s revealed that galaxies are not just moving away from each other, they are accelerating away. This discovery led to the idea of dark energy, some mysterious force or property of space itself that drives this acceleration. But here's where the void hypothesis comes in. If we happen to live in a large enough void with much less matter than average, then the gravitational pull from the surrounding matter would be weaker. Light traveling toward us from distant galaxies would pass through regions of varying density, and this could create effects that mimic cosmic acceleration. In other words, maybe we don't need to invoke dark energy at all. Perhaps the universe only appears to be accelerating because we're in a big cosmic bubble. This would be a huge deal. It would mean revisiting the foundations of cosmology. Most of our models assume what's called the cosmological principle, the idea that the universe is homogeneous and isotropic on large scales. Basically, that no matter where you are in the universe, things look the same on average. But if we're in a big void, then our location is special, and that principle would no longer hold. So, could this be true? Over the past 2 decades, cosmologists have looked hard at this idea. Several detailed models have been developed that describe how a void could affect observations like the cosmic microwave background, the afterglow of the Big Bang, or the distribution of galaxies. The problem is that these models predict certain signatures, like distortions in the cosmic microwave background, that we simply don't observe. The cosmic microwave background is remarkably uniform, with only tiny fluctuations that match what we expect from dark energy-driven expansion, not from a giant void. Moreover, the size of the local void, while significant on a galactic scale, is nowhere near large enough to account for the acceleration we observe. To mimic dark energy, we'd need to be in a void that's hundreds of millions of light years across, with an extreme lack of matter. And detailed surveys suggest this just isn't the case. That said, studying voids has taught us a lot about the structure and evolution of the universe. These regions provide unique laboratories for testing our ideas about dark matter, galaxy formation, and the behavior of gravity on large scales. and they remind us that the universe is far from uniform. It's a rich tapestry of dense clusters, intricate filaments, and vast, hauntingly empty voids. So, are we living in a cosmic void? The best evidence suggests that while we are near an underdense region, the local void, it's not big or empty enough to fundamentally change our understanding of cosmic acceleration. Dark energy still seems to be the best explanation for why the universe's expansion is speeding up. But the very act of asking the question, of testing whether we're in a void, strengthens our confidence in the standard model of cosmology. And beyond that, the idea captures something essential about our place in the cosmos. We're part of this vast, interconnected web of matter and dark energy, shaped by both the dense clusters and the empty voids. Every time we map a new part of the universe, we gain a deeper appreciation of just how strange and beautiful it all is. So, next time you look up at the stars, remember, even the emptiest parts of the universe have a role to play in the grand cosmic story. And who knows what new surprises those voids may hold. If you enjoyed this journey into the structure of the universe, make sure to like this video, subscribe to the channel, and hit the notification bell so you don't miss any of our future explorations. And let us know in the comments, do you think the universe still has major secrets to reveal about dark energy, dark matter, or cosmic voids? We'd love to hear your thoughts.